Welcome to One Question at a Time, the SAT series. Question number 28. In the figure shown above, O is the center of the circle, and its shaded region is a semicircle with O as the endpoint of a diameter. A point is chosen at random inside the circle. What is the probability that the point lands in the shaded regions? So we have a few keywords here. Probability, okay. We have the circle, and the regions, set regions, all of the whole regions, right? So at looking the figures, we seeing that, let's say the bigger circle will have the radius R, which is from the centers to the point, one point on the circle. And also we see that we have two semicircle, but if we move this part, the bubble part right here, if we move it here, you will have a small circle. Okay, we move it here, we have that. And this new circle here have the radius small r. Small circle has radius small r. And we know that the big R that equal 2r, 2 small r. So this one is R right there, R. See that the big R is 2 small little r. The probability means you will have the part over the whole. So the part here is the shade region. The whole here is the whole or the biggest. Let's say the biggest or the outer circle. The area, right? Area of bigger circle. Yep. So let's get into it. Now we have to find the area of the bigger circles with radius big R. First we have to review on the formula. The area of the circle is pi r squared. Okay, so for the bigger circle, we will have pi big R square. For the small circle with the radius little r, that is pi little r square. Now we have to convert the big R into small r. We have pi, and then the big R is 2 little r right here, right? 2 little r square. Simplify this one, we will have pi, distribute that 2 inside, we'll have 2 square times r square little r square. Now simplify it again, we have 2 square is 4 times pi 4 pi little r square. Okay, now we already have it. This is our whole part. This is our small part, right? Now probability will be, it's land on the shake reason will be the part is pi r square over the whole is 4 pi r square. Now we cancel the pi, cancel r square. What left here is 1. Okay, so it's 1 over 4. Also, this one, if they do it at the percentage or the decimal, it will be 0.25 or 25%. So the right answer is C, 1/4. Usually the most common mistake here is people compare R to small r, and they say is double, right? So they only thinking the area of the little one will be 1/2 because of the factor 2 right there. It's like r over big R, that is r over 2 little r, that is 1/2. But in this case only right? This case only right for the perimeter, since r have only power of 1. If we forgot, we can review on the perimeters P that equal 2 pi r. And you see that we see nothing here, mean r is r to the power of 1. So if we're talking about the perimeters, this ratio will be right. But we're talking about the area. So the power here from the radius is square. So it means you have to square it. Okay. When we square it, we will have r squared over 2r R square. This is for the perimeters. Okay. Now this one will have R square over 4R square. That is 1/4. The only thing affects the probability here is just to compare the ratio of the small radius to the bigger radius. Because we have pi is in common already, right? Pi is the same, only changing is r, the radius. Okay, so this is the area ratio. So let's summarize this one. If we have the ratio, the probability of the small over the big one, that will be little r over the big R for perimeter. It will be equal small r square over big R square for the area of circle. Thank you for participating in this series and see you next time.